Okay, now you can see that a satellite is orbiting the Earth. Okay, so the blue arrows show the direction of gravitational forces, okay, the attraction forces between the Earth and the satellite. Okay, now the satellite is orbiting. Okay, the red colored arrow shows the direction of the velocity. So if the satellite is moving with a uniform speed, what about its velocity? Okay, this is another simulation. Okay, we are using scaled diagram. Okay, so if the scale diagram, in order to show the distance, the far distance between the star, now the star is the sun, the planet is the Earth. Okay, so the Earth and the planet is very small, drawn small. Okay, so this is the sun. Okay, this is not a scale drawing diagram. Okay, the sun has a force towards the Earth. The Earth also has another force acting towards the sun. Okay, now the Earth is orbiting the sun. Okay, the speed is uniform. So if you look at, okay, what is the meaning of velocity? Velocity is the rate of displacement. So if you look at the red arrows, okay, the red arrows always changing its position, its direction. Okay, the direction is always changing. So when velocity change, so when the direction of velocity change, we see that the velocity also change. When the velocity change, is it accelerating? Is the Earth accelerating, or is the satellite accelerating? So what is the definition of acceleration? Acceleration is the rate of change of velocity. So since the velocity is always changing, hence there is change in velocity, therefore it is accelerating. So the Earth is accelerating when it is orbiting the sun, and the satellite is also accelerating when it is orbiting the Earth. So when that happens, centripetal force is always present. Okay, so centripetal force is the force needed. Okay, so centripetal force is always pointing towards the center of the circle, or the center of the orbit, the center of the motion. So here is an activity to understand centripetal force using centripetal force kit. Okay, so when you carry out this experiment, you can refer to this video. Okay, you hold the plastic tube in your hand, okay, and then rotate the rubber stopper at a constant speed, okay, as shown. Make sure the crocodile clip stays at about 1 cm. Okay, so when you do that, okay, refer to the video so you can get the centripetal force. Okay, centripetal force is a force acts on a body in a direction towards the center of the circle. So what's the relationship? So we can relate the mass and the radius of the linear speed and also the force, the centripetal force. So the relationship is force is equals to mv squared over r. So force is directly proportional to the mass. force is directly proportional to the speed squared, and force is inversely proportional to the radius. So now we look at an example. So how do we solve these problems? Now the question wants centripetal force. So as usual, we should write down the information given first. And then we write the formula and substitute the values given. And then you calculate the answer. So the answer is